Hello, in this video, we're going to solve DP Chemistry HL Specimen Paper 1A, and you can expect this kind of paper in May-June 2025 exam. So let's get started. As you all are familiar with paper 1A, so in paper 1A you have to attempt 40 multiple choice questions. Now, let's start with the very first question. As you all can see, what is thin layer chromatography best used for separating? Now, we all know that thin layer chromatography has two phases. One is mobile phase and another one is stationary phase, right? So the best part of doing multiple choice question is to look for the wrong options and start eliminating these wrong options. As you can see, molecules of varying polarity is our first option, molecules of similar polarity, metals in alloy, and water of crystallization from hydrated salts. So you see that only the molecules with a varying polarity can be separated due to their different polarity towards the mobile and stationary phase. So 1 is the most appropriate option for this question. Question number 2. Ice containing only the isotope H2 sinks and does not melt when dropped into ordinary distilled water maintained at 3 degrees Celsius. Which statement is true? Now, before we look at the options, you need to understand that hydrogen contains 3 isotopes. One is H1, H2, and H3, right? So the most stable of these isotopes is H1, which we see in our daily life, right? And yep, so H2 sinks. So usually it sinks and does not melt when dropped into the ordinary distilled water at 3 degrees Celsius, right? Now let's look at the options. Which statement is correct? The isotope H2 has natural abundance. This is not correct option, because if it has the maximum natural abundance or high natural abundance, then the relative atomic mass of hydrogen could be somewhere around 2, right? But this corresponds to the wrong option, right? It cannot be 2. Second option is that H2O2, which is heavier isotope of water, has higher melting point than normal ice. So this can be considerable option, but we have to look through the other options as well. So H2O has lower density than normal ice. No, you see, as they are telling that it sinks, it reflects that it has higher density. So this can be wrong option. And H2O has different chemical properties from normal water. Now, we know that isotopes, they have similar chemical properties. Similar chemical properties. Why is this so? Well, they have similar chemical properties as they have same electronic configuration, right? So this is also a wrong option. So the most appropriate answer for this question is B, right? Let's move towards question 3. Now, question 3 is from successive ionization energies, right? This specimen paper will also give you an insight that what kind of questions can you expect in exams and what is the pattern or sequence of the questions. So in this question, you have to analyze the ionization energies given, right? And you have to predict what is the formula of this oxide of the element Z. Now, if you look through the ionization energies trend, they are increasing, right? Let's say we have the first ionization energy, which is 577. We have second one, which is 1816. Third one is 2744. Right now you see there's a gradual increase. They're increasing gradually, and there is no huge jump between all these three. But when we move towards the fourth ionization energy, there is a significant jump, which is 11,577.5 kilojoules per mole. So this right there is a huge jump. What information can I deduce from this? That they have 3 electrons. First 3 electrons were easy to remove, but when it comes to the fourth electron, you need to provide a lot of energy. A lot of energy means that this electron is quite stable. So it can give me a clear overview that it has 3 electrons. So Z will be having a charge of +3, because on removing 3 electrons, you will gain a charge of +3, right? And oxide, we are already familiar that oxide belongs to group 6 of the periodic table, means it has 6 electrons in the outermost shell. So it will gain 2 electrons to form a stable noble gas electronic configuration. So oxygen has a charge of -2, right? So when we cross their valencies, we will be getting Z2O3, right? So C is the right option for this question. Okay. Now we have question 4. A container holds 30 grams of argon and 60 grams of neon, right? So you have two noble gases. One is 30 grams of argon and another one is 60 grams of neon. What is the ratio of number of atoms of argon to number of atoms of neon in the container? Now, the first thing is always convert the given data into moles. So let's find the moles of argon first of all. Now, for finding the moles of argon, we need to divide 30 divided by the atomic mass of argon. 30 divided by 39.95. And for those of neon, we have 60 divided by 20.18. Right, now when you calculate these values, you will get the answer, which is 0.75 and 2.99. Right, now you have to get the ratio of number of atoms of argon to the number of atoms of neon. So let's divide argon with the neon. So what do we get? 0.75 divided by 2.99. So when you just calculate these values, you will get 0.25. All right, here we have question number 5. Now, a gas storage tank of fixed volume V contains n molecules of an ideal gas at 300 Kelvin. Now you are given with a temperature with a pressure of 40 kilopascals. N by 4 molecules are removed and temperature is changed to 450 Kelvin. What is the new pressure of the gas? Now, before we start doing this question, you should be very much clear about the general gas equation, right? So that is P1 N1 over T1 equals to P2 N2 over T2. Now you need to understand that we need to calculate P2 over here. Now the initial pressure, what is the initial pressure which is given to us? P1, that is 40 kilopascals. P2 we have to work out. N1, which are initial moles or initial molecules, they are N, and we have N2. Now you see for N2, N by 4 molecules are removed. So how many molecules are left? That are 3 by 4N, right? And you have T1, which is initial temperature, that was 300 Kelvin, and T2 is 450 Kelvin as given in the question. Now we have to rearrange our equation to get P2 as a subject, right? So in order to do this, we have to multiply with T2 on the other side. So let's quickly multiply this. P1 N1 times T2 over T1 equals to P2 times N2. Now let's plug in the values to see what we get. Yep, so here we have T2, which is 450. So let's put 450 times P1 40 times N1, which is simply N, over, yes, you have to bring this to this side, you need to get P2 as a subject. So we'll be getting T1, which is 300 as given in the question, and yeah, N2, which is going to be 3 by 4N, right? 3/4 of N. So as when we write down the fraction as a denominator, we have to write it down like this, 3 by 4N. Okay, so let's quickly solve this. And what do we get? So this N can be cancelled with this N, right? So 0 can be cancelled with this 0, this 0 can be cancelled with this 0. So 4 1s are 4, 4 1s are 4, and this 3 can be cancelled with this 3. So we are left with 45, right? So the new pressure, which is P2, is going to be 45 kilopascals. So C is the right answer for this question. Let's try question number 6. This question is from the atoms, ions, and writing formula of the ionic compounds, right? So for this question, what you need to do is, what is the formula of the compound formed between magnesium ions and hydrogen carbonate ions? We know that HCO3 has a charge of -1. So this is polyatomic anion, right? So, and you have magnesium, and we know that magnesium belongs to group 2 of the table, and it has a charge of +2 because it will donate 2 electrons to form stable electronic configuration. So when we just interchange their charges, what do we get? We'll be getting Mg HCO3 twice. So the right option is B. Okay, so question number 6. In which group of ions and molecules are electrons delocalized? When we talk about delocalized electrons, I mean to say free electrons. Right? So if we just analyze all the structures, right, as far as the first structure is concerned, there are very less or no free electrons. When we look through the C, so diamond has no free electron because all the carbon atoms are linked in a tetrahedral structure with the other, and each carbon atom is making 4 bonds, so leaving no free electron. When we look through these species, they also do not contain any free electron. So one most important hint that I'm getting from here is these negative charges and graphite. Right? So these species have free electrons as they are anions, okay? And graphite, in every graphite atom, you will notice that each carbon atom is linked to 3 other carbon atoms, leaving 1 free electron. So graphite is a very good conductor of electricity because of this reason. So the most appropriate answer is, when we eliminate the wrong options, we'll be getting B. Right? Now, let's try this question. This question is from the ligands and geometry of compounds, D block elements, or geometry or molecular geometry. Right? Now, what is the molecular geometry of SF4Cl2? Whenever the central metal atom is linked to, let's say, 6 other carbon atoms, like we have fluorines and we have chlorines, then the geometry over here is octahedral. Right? So whenever it is linked with 6 atoms, 6 different atoms, the geometry is going to be octahedral. Right? So you can, this is octahedral geometry. Right? So D is the right option for this question. Now, when we look through question number 9, which is the preferred Lewis formula for nitrous oxide, which is N2O, as deduced by the formal charges. Now, for N2O, you need to understand that all these structures cannot be possible. Right? Now, we all know that nitrogen has 5 electrons in the outermost shell. Right? And it can form a triple bond with the other nitrogen atom. Right? And when it can form a triple bond with the other nitrogen atom, right, and it will be having a positive charge, and we have the oxygen atom with the 6 other electrons. Right? So the most appropriate option out of all these options is B. Right? Now, proceeding further, and remaining all options are incorrect. Okay, look at this structure in question number 10. Which pair of statements about electrons in this molecule is correct? Now, you need to look through it very carefully. Right? So for the first column, number of non-bonding electrons, which are also known as lone pair of electrons, and on the other hand, we have the number of electrons in the pi bonds. Right? So usually single bond is a sigma bond, and whenever there's a double bond, we call it a pi bond. Right? Now, first of all, let's look through the number of non-bonding pair of electrons, the electrons which are not involved in bonding process. So this oxygen has 2 lone pairs, this nitrogen has 1 lone pair of electron, and this oxygen has 2 lone pair of electrons. Right? So how many pairs do we have? 1, 2, 3, 4, 5. So this row is C and D. So we have to look through C and D. We can eliminate A and B. Right? Now, number of electrons in the pi bond. Now we have to understand how many pi bonds are there. Okay. Every benzene ring has 3 pi bonds. Right? So there is one double bond, let's say 3 double bonds in the benzene ring, and 1 double bond is present over here. Right? So every pi bond has like two electrons. Right? So we have 4 pi bonds or 4 double bonds. 1, 2, 3, and 4. So 4 times 2 equals to 8. So we have 8 electrons. So D is the most appropriate answer for this question. Let's talk about question number 11. What is the explanation for the malleability of metals? Yep. So the bonds are strong. Bonding has nothing to do with malleability. Right? So malleability means that metals can be molded into any fixed direction. And that is only possible because the bonds do not have any specific shape. If we look through the structure of metals, we'll get to see that they contain a lattice of positive ions, right, with a lot of delocalized electrons, right, surrounding the metal. So they do not have any specific direction for this bond. So this right there is the electrostatic force. Electrostatic force between positive metal ions and sea of delocalized electrons. So D is the most appropriate option for this, right? Others are all wrong options. Let's talk about question number 12. Now, this question is from organic chemistry, and this question is about the polymers found in some plastics. Which monomer is used to form the plastic? Now, this question is very easy. Whenever you're given any polymer and they ask you to deduce monomer, first thing you have to do is write down the displayed formula of it. So we have carbon, and let's write down the displayed formula first of all. And we have carbon CH3 and CH3 over here, right? So all these bonds are displayed as they are in this diagram. Now, if this is a polymer, what will be the monomer? For the monomer, you need to create a double bond over here at this position, right? And you have to satisfy the valency of carbon. Now, when we draw the monomer of it, we have to create double bond over here and satisfy the valency of carbon. So this right there is your monomer, right? So the most appropriate option is we have two methyl groups and we have two hydrogens, right? So that is going to be two methyl groups and two hydrogens. So A is the right option. Now, let's talk about question number 13. Why is copper 2 sulfate blue? Now, this question is from the chemistry of transition metals and color compounds. Now, what you need to understand over here before we jump into the question, you need to understand that when we talk about d subshell or d orbital, right? So d orbital is basically of 5 main types. 1, 2, 3, 4, 5, right? Now, 2 of the orbitals are high energy orbitals and 3 of the orbitals are low energy orbitals. Okay, different cations show different behavior and different color, right? That is because when the electron jumps after emitting after absorbing the radiations, it jumps from this energy level, lower energy level, to the higher energy level. If I could label the energy levels for you, this is dxy, dxy, dyz, and dzx. And these two orbitals of higher energy are dx square minus y square and dz square, right? Let's say electron is present over here in this ground state. It will absorb energy and it will shift to the higher energy state, right? Now, how does it gives color to the compound? Well, it depends on the radiation that it will absorb. Since copper sulfate appears blue to you, right? So you need to understand that blue color is only emitted when red light is absorbed, red or orange range is absorbed for this. So red light is absorbed when electrons are promoted between the orbitals in the split d subshell. So we have seen the d orbital being splitted, and when electron jumps from here to here, so you need to remember that red or orange wavelength of radiation is being absorbed and blue is emitted. So that's it. So let's talk about question number 14. Which molecule has a carbonyl functional group? Now we all are familiar with carbonyl functional group. That functional group is C double bond O, right? So out of all these structures, you will notice first guy, this right there is an ether, right? So this right there is a ketone. So we have CH3, CH3. So carbonyl group is found over here in the B. As far as others are concerned, they do not contain carbonyl group. Let's try question 15. The block structure of periodic table groups elements according to which characteristic? Now, the block structure. You need to understand that elements are arranged in different blocks. S block elements, okay, P block elements, D block elements, which are transition metals, and F block elements, right? So they are arranged in different blocks. Now, what will determine that which block an element contains? Atomic number? No. Atomic mass? No. Reactivity? No. The only thing which indicates or which will decide that which block element needs to be placed, that is electronic configuration, right? If the electronic configuration falls in the S block or S subshell, the element will be the part of S block. If electronic configuration falls in the D subshell, the element will fall in the D block element, right? So C is the most appropriate answer for this question. Let's talk about question number 16. Which D block element has the highest number of different oxidation states? So we have different elements written over here. We have titanium, manganese, copper, and zinc, right? So you need to look through the electronic configuration that all these elements are D block elements. Okay, all these elements are D block elements, but you will notice one thing, that if you take potassium manganate and you need to look for the oxidation state, let's quickly find out the oxidation state of manganese over here. We have +1 plus X plus oxygen has a charge of -2, so -2 times 4, since we have 4 oxygens, equals to 0, right? So we have X minus 7 equals to 0, right? So X equals to +7. So this is the oxidation state of manganese, which has the highest number. So copper can form +1 or +2 oxidation state, zinc can form +2, in the same way titanium can form +2, +3, etc. So manganese is the most appropriate answer for this question. Now let's talk about question number 17. What do all greenhouse gases have in common? They are emitted by burning of fossil fuels. All greenhouse gases cannot be produced by burning fossil fuels. Let's take an example of methane. So you cannot obtain methane by burning fossil fuels. They absorb ultraviolet radiations. They are symmetrical molecules with no polar bonds, although they still have some polarity in them, so we cannot say that they are non-polar molecules. And they absorb infrared radiations. So D is the most appropriate answer, because they absorb high energy radiations, which are infrared radiations from the sun, right? Now this question is from the nuclear magnetic resonance, or NMR spectrum of spectroscopy, right? Now in this question you have to analyze cyclohexane. Now you all know that cyclohexane is an alkane member, right? It's an alkane member which is written as C6H12, right? It contains 6 carbon ring, right, with the hydrogens attached, right? Now since all the hydrogens, you have to understand that H1 means are of the same type. So what you will notice over here, you will notice only one peak will be detected, right? So only one peak will be detected, and that peak, only one peak is present in A option. So option A is the most appropriate answer for this question. The video is getting too long, and we will be doing the remaining questions in part 2 of the videos, so wait for the video. And if you want to book a free trial class with us, please feel free to book a free trial. We have IB tutors for all the subjects. Thank you so much. Take care. Bye bye.